Okay, fine. Next, let's start with the operators. Okay, see, our approach here is like we are initially taking up all the different kinds of things, okay, and then we'll go into developing a class. Fine, slowly we'll develop a class and make it further and introduce more features related to a class. Okay, class, then we'll go for interfaces and various categories and all those things. So yeah, and so just whatever we know about operators. Okay, what are the various categories of operators, and we know from C language, fine, and then we'll add whatever additional things for Java, or if some operator works slightly differently compared to C. Okay, so we are assuming operators from C language. Yes, we can categorize the operators. Okay, so we have the arithmetic. Let's start with the arithmetic operators. Yeah, what are the arithmetic operators? Plus, minus, multiplication, division, okay, and the modulus. And these are categorized as a arithmetic operator. Should work for the numeric. Fine, we have the numeric primitive types. Okay, so byte, short, int, long, float, double, and char, even char. Yeah, even char. For concatenation. Right? Not concatenation, all of those. Multiplication, everything. Okay, fine. What about the type of the expression? Okay, fine. When we do any arithmetic, what will be the type of the expression? In Java, all this arithmetic is defined only for 4 types. Int type, 32-bit whole number, 64-bit whole number, long. 32-bit floating point, 64-bit floating point. So when you carry out any of those operators, binary, I'm talking about binary as a binary operator, right? The resultant type will be one of these 4 only. We have something called type getting promoted. Fine. There is a conversion, we call it as conversion. Okay. And so we have conversions. So automatic conversion of subtype to a supertype. Okay, what are those automatic conversion of subtype to a supertype? Okay, so if we have operator, the 2 operands, right, in any of those binary operators, the 2 operands which are there, if any one of them, so if I say, let's say there is a variable A and there's a variable B, fine. Okay, we have variable A and B. I've used the word where, but just assume that means it may be fine. We'll try to assign meaning to A and B later and see. Okay, so we have an expression which is A and some kind of an operator and B as a binary operator if we are using. Okay, operator means one of those 5. Okay, fine. So what is the expression? If, yeah, A or if A and B both less than int. If they are less than int, means they are a byte, short, or a char, right? Byte, short, or char. Okay, they would be converted to int. Fine. Fine. So if both of them, yes, fine. Or rather, if any one of them is a, yeah. If
both are less and then it's remaining
The answer is going to be int only. Both become int. When both will become int. Any one of them, the idea is the smaller type gets converted to the bigger type. Okay.
but one is byte second is int.
Huh?
One is byte or second is int.
One is byte, second is int. Byte has to be converted to int. Smaller type to be converted to bigger type. Okay, but at least int. Smaller than int, they have to become int. This is nothing but your how the fine. So then the operator would be applied. First the conversion, then the operator to be applied. So you ultimately will have either int operator int, fine, long operator long. So it's always going to be like this. Okay. The addition, subtraction, multiplication, division, or modulus will happen between two ints, two long, two float, or two double. There's no other thing in our instruction set. As far as this arithmetic is concerned, the arithmetic is defined in JVM in four ways: between two integers, between two longs, between two float, and between two double. So both of them have to be matched, and then so if one of them is a smaller type, make it a bigger type. If they happen to be right, so if they happen to be smaller than a int, they will have to be made as int. Yeah. So conversions, right? These are automatic conversions. At least int. Okay. Fine. We understand how the arithmetic is done, right? Okay. So compared to C language, yes, you can think that modulus was not defined for the floating point type. Here it works even for float and double. Okay. Fine. Then what's the other one? Okay. String concatenation. So what is the string concatenation? The character used is plus, right? The symbol used is plus and reused. Plus used as a binary operator for numeric type. So if operands are numeric, we understand. But here plus for string concatenation. Okay, fine. Now another thing about string as a data type is all types, any data type is always convertible to a string. And all data types can be converted to a string, including all kinds of reference types. Okay, every type is convertible to a string. Okay. And so that's one thing. Okay, when any of the operands, any one of the operands, at least one operand, is a string, and you have used a plus, and it will be considered as a string concatenation. Okay.
So you can't convert string as a, you can't convert string.
We can't convert
string number को हम string कर रहे हैं ना.
हाँ हो जाएगा.
String को
not with the help of the operator, not with the operator. You will have methods to convert from string to the other types. And it depends what type you want to convert to. See, why we have that class called integer? So that string, we will have a function which can convert string into the int type. From string to int. Where do I keep it? We need a utility to convert from string to a int type, or from int type to a string. Where do I keep those functions? That's where we have the wrapper class, and the class type corresponding to the primitive int. It's nothing but library basically, and those classes are nothing but libraries basically, right? Utility functions. Okay, fine. When any of the operand is a string, it is used as a string plus is used as a string concatenation. Okay. Okay, let me show you one simple example so that we understand the difference. Okay. Now again, it's going to go from left to right. Okay. Okay. What's the result of this? What will be done? Going from left to right, it will do this. That means it will become 5 plus 5. 10 plus is 10. What's the next step? Convert this into a string. So if any of the any one operand is a string, the other will have to be converted to a string, and then carry out the string concatenation. Okay, and therefore it becomes, and yeah, these are the steps. Whereas what happens here? Okay, carry out this first. Okay, fine. So that means it would be, okay, fine. What's the next step? This becomes 5 here. Okay, and in the next step, convert this number to a string, and then that becomes, okay, oops, yeah. Clear how string concatenation works? Anything will be converted to a string. Suppose we have something like this, string. Okay, instead of string, let me say we had what? We had some other class. Okay, someplace we have something like vehicle v equals, and someone says null. Okay. And then he says, oh, let's have, okay, v is plus v. Okay, how will this be converted? And on that side, if it is to be converted, if that's null, or that will be converted like this. And this becomes v is when used with a concatenation. Yes, the conversion of a null will be possible. So even that literal null gets converted to a string. Everything convertible to a string.
Because mainly we use string for displaying something, right? So
Yes.
whatever is there in the memory, We should be able to convert to
Yeah, yeah. How a particular reference type will be getting converted to a string will be decided by that type. This is a type, right? So when you define your own type, right? When you define your class, you will be responsible for defining how the string conversion takes place for your type.
because mostly I think string is only for the consumption of us humans.
Yes.
We are the ones who are
Of course,
consuming
but
string.
there's a lot of data which is as a text data. So all that text data is a string for us. Okay. And
But for computer, when we give a string, it has to be converted to a number or whatever.
everything is number internally, right? Every character has a number, and we have that character set for that purpose. So fine. So it's always, anything which the computer is trying to show, it wants to know whether you would like to see it as a text or should I treat it as that numeric value. Okay, that's where the type comes in. The type is a char type, the type is a string type, it represents text, otherwise it's a binary. Oh, the type is a float or a double, then that same set of bytes will be treated differently compared to how if it was said to be a int or a long type, right? Same number of bytes, sizes are same bytes, but what value should it be representing, right? So it's all bits, sequence of bits, lower level, right? Okay, fine. So fine, string concatenation. What next category? Arithmetic is finished. We have seen the string concatenation. We have the okay. Before logical, we have the comparison. Comparisons. Yeah, comparison. Which are those? Less than, greater than, less than equal to, greater than equal to, and not equal to. Okay. Out of this, right, the first four they are not meant for any other type other than the numeric types, numeric primitive types. Okay. Right. Okay, and then the okay, fine. Now we'll have to understand. Okay, just I'll put out the special cases here. Fine, we understand those first four, but there are few special cases which are related to the infinity and NaN. Okay, so let's understand like this. Maybe I have got I'll take example of a double. Okay, and let me have a variable name called nf equals, and this I can pick from here also. Okay, see, that's a placeholder for keeping those special values also. Okay, that special value of positive infinity, that's available directly also, right? So you need not be saying, okay, let me do this divide by this. I have a variable called nf. Okay, now what about this? So if you have a less than inf, that's always true. Okay, so positive infinity is greater than any other value. Same way, negative infinity always less than any other value. What about comparison of NaN? NaN is a very special case. It's not a number, right? Okay. Okay. So what is this NaN? Not equal to NaN, not equal to anything. No, that's true. If you say NaN less than A, no, false. Is it greater than A? False. Is it equal to A? False. Right? Including someone saying NaN is NaN equal to NaN? What do you think? True or false? See, you compare with itself and it says false. It's not equal. And so that's a special case for comparison. Right? Fine. So not equal to is going to return true for this value. All other comparisons are always false. Okay, except for not equal to, all other comparison operators will return false. Fine. We know comparison will always result in a Boolean expression. Okay, that becomes a Boolean. Okay, fine. Now we'll have to also understand about the equal to and the not equal to part. Okay, for reference type. Equal to, not equal to, we understand with numerics. Fine. Again, Boolean and numeric, you can't mix them for the comparison purpose. Okay, numerics are separate, Boolean is separate. You can't be comparing for true with a numeric type. Fine, true, false, don't compare them with the numeric types. Okay, they are separate types. Okay, but one thing let's understand is related to the okay, fine. Now we understand reference types, right? If I have a string, not string, let me take some other thing. Okay, let's say we have, someone has defined a class called date. Okay, and there is, let's assume there is a class called date, right? And date, from our understanding, initial understanding, we'll think, okay, date is made up of day, month, and year. So internally, it would keep day, month, and year. So fine, I have date D1, okay, and equal to, and at this moment, we'll not worry about how do we create an object, and we have not yet seen the syntax for that. Okay, but it would have some object, right? And I have date D2 also having some kind of an object. Okay, and they are, for example, yes, we have something like, so the figure goes like this. We have D1, and let's say it is having an object in which today's date, so we have 13th December, okay, and 202, okay, right? So that's what it is, D1 is, okay. We have D2 as a separate object, and it has been allocated a separate object, and this has got, so what do you think, are the two dates equal or not? Are the two dates equal? My question is simple, it's in plain English. We're not looking at that operator currently, we are asking whether are the two dates equal? Fine. But if I ask for whether D1 double equals D2, what do you think? True or false? This is false. Because double equal to for reference type is not about equality. It's not about equality of the object. It says, is it the same object? The double equal to only checks whether is it the same object. Is D1, D2 the same object? No, they are two distinct objects. Fine, clear? So for reference type, the double equal to and equal to not and that not equal to is about whether it is the same object or not. Okay, it's not about equality, it is about being the same object. Fine. Okay, you want to talk about equality, and if you want to know about equality for a reference type, then we should be using d1 dot equals d2. Okay, now whether this will give me true or false, it depends on the type. The one who has defined the data type date is responsible for defining the equality, but equals is what is used for knowing equality for two objects. Okay, fine. Just like, the one who defines the class is responsible for defining the string conversion. Same way, he is also responsible for defining the equality. So if you want to know about equality of two objects, use equals and not the double equal to. Double equal to, if you want to know if it is it the same object. Yeah, equal to is a different idea, and is it the same object? That's a different idea. Fine. The double equal to is for is it the same object. Equals is used for is it the are the two things are the two objects equal? The equality part. Right? Equality is different. Yeah. Okay. Just like I've mentioned about equals. Right? When we were looking at the string conversion, okay, we have something called toString for string conversion. Okay, just go back to that string conversion thing, and let's put that here. Okay. Right. So that should be clear. Okay, just go back to the string concatenation thing over here. Okay, if v was not null, okay, then so it would use v dot toString. Okay, provided it is not null. If it is null, it won't be doing v dot toString. It finds it's null straight away. Null gets converted into the string null. Okay, Fine. So it's not that somewhere if I write v dot to string, if v was null, it would be an error if someone writes v dot to string. But if you use with plus, okay, right? So if someone says v is plus v, okay, fine. Unless v is null, okay, it is same as saying but if v is null, no, then this, so this, the difference between these two expressions, okay, they would give the same results till v is not null. But if v is null, then this one is an error, whereas this is going ahead with a conversion saying, oh, that needs to be converted as null. And here you are not asking it to do a string conversion, you are assuming it's not null and you are doing the string conversion from the type. So v dot to string is nothing but string conversion available from the type vehicle. Okay, so a type defines its string conversion, a type should also define the equality. Okay, when we'll look at it more when we, right? So there'll be more information on all those things, right? But okay, so comparison is fine. Next comes the logical operators. Okay, logical operators, yes, which are those? And or then XOR, yeah, and or XOR, then not, yeah, and yeah, yeah. The last two are, we call them as short circuit. They are the short circuit operators. And the last two of them are the short circuit operators. Yeah, so what's the difference? How do they work? How are they different from the first two? Yeah. Okay. Fine. Quickly understand with the example. Fine. B equals 7, maybe something like this. Okay. And then we put if A is greater than 5 or 6, maybe. If A greater than 6, and you might say and then we have plus plus B is less than 5. It doesn't make much difference here. We understand this is all going to be, this is never going to execute, right? It won't enter inside the if. So question here is the value for B. What's the value for B? Right? This would be 8. Okay. Let's repeat. So only difference what we are having is we are making it double ampersand. Yeah. This should be. The idea here is the short circuit means, if the value of the expression can be determined from the first operand, the second operand is not evaluated. Okay, the second operand is not evaluated. Okay, and first is false, and therefore the expression is going to be false. It will not go on the second operand to evaluate it. Okay, same way, if it was the OR operation, if the first is true, it won't evaluate the second one. Okay, short circuit work in this manner. Fine. See, the second side, what I have done, I have just said, okay, plus plus, I'm making some changes there, right? It could be, there might be a method which is returning a Boolean. So whether that method gets called or not, that can be determined by the first operand. It's like invoking the method which is returning a Boolean value. And it could have been, right? This part, the second part could have been a method invocation which is giving me a Boolean. So this method is getting invoked if this is false, if this is true. If this is false, this is not getting invoked. As well as, now the whole expression depends on that Boolean also. That anyway will be there. Yeah, but yeah, you see the difference now? Okay, so short circuit, right? Okay, yeah, next category. What's the next category of operators? Bitwise. Yeah, okay, some differences. Yeah, which are the bitwise operators? Yeah, bitwise operators. Okay, those are the shift. Oh, bitwise. See, those things, the operands are, when we use the logical operators, the operands are Boolean type, not the numeric type. Whereas this is for only int and long. The bitwise operators available for the type int and long. Less than int gets converted to int. We understand that. Okay, so even byte or short or char would work, but ultimately that's converted to an int. So it's a 32-bit int value or a 64-bit long value that we'll be working with when we talk of bitwise operators. Okay, so we have AND, OR, XOR, the complement, and that complement is unary operator, just like the NOT operator is unary, and that exclamation sign in logical is unary. So here complement is a unary operator, and then we have the shift operators here. And these two we are familiar in case of C. This is also there. We call it as the unsigned right shift. Okay, it's the unsigned. Yeah. Okay, now there are differences from C, the way it is done. Okay, so I'll show. Fine, we understand AND OR XOR. Oh, they are exactly like what happens in C. Yeah. Okay. AND OR XOR. The first four are fine. There's just like what happens in C language. What happens? Bitwise AND. Okay. If required, conversion will be promotion to int or long will be done if they are smaller, and as required. Okay. What about the less than? The shift operators. Left shift. So let's see the left shift. Okay. So I'm just showing the difference with the C language. Okay. Only the difference from C language. So if I say A left shift 3, that's one. And if I say A 67. What do you think that second one will do? Left shift. Left shift means bring in zeros from the left hand side. Bits will be zeros and 0 bits will be pushed. How many? Left shift 67 means should make it all zeros. That's what would happen for C language, not in Java. What happens here in Java is the second operand is brought down to a value in the range from 0 to whatever is the length minus 1. The number of bits in that type, either 32 or 64. A is 32 bit or a 64 bit. It would work on both of them. If it's a 32 bit, yes, bring it in the range from 0 to 31. And how will it bring it in that range? Reduce by the size. Or 67, reduce by 32, reduce by 32, till you get 3. It's like almost taking a modulus, so almost like that. Okay, so these two are same. Both these expressions are going to do the same thing. Okay, the second operand will be brought in the range from 0 to n minus 1, where n is the number of bits in the first operand. That number could be 32 or 64, int or long. Fine, clear? Okay, what is right shift? If I do A, so this is first part, right? So for any of those, for all the three of them, the second operand, fine, a shift means, yes, I won't shift out every bit. And all bits cannot be shifted out. So your value cannot be more than the size, more than or even equal to the size. If you say equal to size, I'm not doing anything. If someone says left shift 64, it's not shifting at all. Okay, fine. Okay, how is this going to work? Fine, we understand. What is right shift going to do? Okay, let's see with an example like this. So let me show the bits here, right? Let's see. Okay. Okay, fine. If I say right shift 3, what would be the answer? The result would be right. Yeah, and that's clear. Fine, how this comes, right? That's okay. Right. Now I'll change the value slightly. Okay. There's only one change I'll make. Okay, now tell me the answer. Yeah. What's the answer here? This, anyway, you're expecting this to be 1, that's fine. Yeah. Is this what the answer would be? It's a sign, but it keeps the same sign. A negative value remains negative. And you start with a 1, that means a negative value. So negative remains negative. Okay. Fine, this is how it works in Java, because int is a signed type. See? Int is a signed data type. When you do a right shift, Yes, it's doing a right shift which is with the sign bit. So when you do a right shift, the sign will not change. Positive remains positive, negative remains negative. Most significant bit क्या है पहले वाले में? This is 0. That means it's a positive value. Right? So it got shifted, right? This has gone here. Sorry. Fine. This has gone here. Right? Right? And what has entered? 3 zeros have entered. Okay. Okay. Now here in this case, it's a negative value. Most significant bit is 1. Fine. This has gone here, right? Right? Okay. But what has entered? Because it was 1 here, it will bring in ones only. So a negative value remains negative after shifting. Yeah. Okay. So now what is unsigned right shift? What is unsigned right shift? If shifting happens, it will become positive because it brings in zeros, not the sign bit. That one brings in the sign bit, this one brings in the zeros. Yeah? That's a unsigned right shift. This is typically what happens here. Let me explain the comparison with C language. In C language, the type is declared to be signed or unsigned. Okay, so in C language, if you have an unsigned int and you do a right shift, this is how it will work. If A is an unsigned int, if A is just a signed int, this is how it would work. Okay, so we have, because we don't specify signed or unsigned in Java. Okay, so we got 2 operators for that. 2 separate operators are available. Sorry, I should have said this one. Fine, clear? Okay. Fine. Another thing here. Okay, some more operators. So fine. So this is bitwise operators. Yeah. We are just see whatever it is like C language, we won't discuss it much. Okay. Anyway, bitwise you may not directly be using most of the time, but all the lower level code is using this kind of things. Okay. There are many places where this is used, but you may not be using it directly. Okay. Yeah. What other category of operators? Some other, I think no other category, but yeah, let's have like this: assignment and cast. Okay. What is assignment and what is cast operator? I think we'll continue tomorrow. Okay. Fine. So tomorrow I think we'll continue for the operators and then we'll move to the statements. What are the statements, if, else, and all those things. And we'll be discussing mainly how it differs from C language. And what we know from C language, and we'll not be discussing them, but we'll discuss the differences, wherever differences are there. And the new things which are available. There are a few more things in the operators. There's one more operator which I'll be discussing. It's called the instance